It's all about inverse function, lesson 1.6. Students will be able to find the inverse of given function or a graph. So a quick review and how do we evaluate a function? Exercise 1. Consider the two linear function given by the formula f of x is equal to 3x plus 7 over 2 and g of x equals 2x minus 7 over 3. I want to evaluate f of 5. So f of 5 meaning I'm using my f function, which is right here, and I want to see wherever I see x, I'm going to put 5. So this becomes f of 5 is equal to 3 parentheses 5 plus 7 over 2. 3 times 5 is 15 plus 7 is 22 divided by 2 is 11. It says also to find g of 11. Now remember, the letter tells me which function I'm using. G of x is this function right here, 2x minus 7 over 3. So this becomes 2 parentheses 11 minus 7 over 3. 2 times 11 is 22. 22 take away 7 is, great, 15 divided by 3 is going to give me 5. Let's try 2 more. F of 0. Using my f function, so this is 3 times 0 plus 7 over 2. This will give me 0 plus 7, 7 over 2, or 3.5 is fine. Either one works for me. Now, g of 7 over 2 is equal, I'm using my g function, 2 parentheses 7 over 2 minus 7 all over 3. My 2's are canceled. This becomes 0. So, if you're not sure on how to do this for the second one with the fraction, enter this in a calculator. It should look exactly the way it is. So what you're going to do is pause the video and try C and D. Yes, you're going to try it. You're not going to just copy the answer. Try these two on your own. Good. Now you got a chance to try this. Let's see. Did you really get -1, -3, and then a +5? Because this is a composition. So my one answer here is a 5. Excellent work, guys. Now today we're going to talk about inverse. If a function y equals f of x has an inverse that is also a function, we represent it as y equals f to the -1 parentheses x. F to the -1 is read as f inverse, or the inverse of f. Okay? So, if a point -3, 5 lies on a graph of y equals f of x, which of the following points must lie on the inverse? So, when you have some kind of coordinate points, and in this case it's -3, 5, the inverse is kind of when you switch it. So all I'm going to do is switch my x and y value. So I have -3, 5, and then the inverse becomes, switch them, 5, -3, which is choice 2. So whenever you're dealing with a coordinate pair, all you have to do is switch your x and y value. Finding the inverse on a graph. So I have a linear function of 2 over 3x minus 2, which is shown on this graph below. Use the graph to answer the following questions. So before I even do that, what I want to do is graph my inverse function. So remember, I'm going to graph my inverse functions. So at this point here, it is 1, 2, 3, 4, 5, negative 6, negative 6. So if I have this, and I'll take this off, so I want to graph this, okay? So I have negative 6, which is right here. If I was to do the inverse, this point right here is 1, 2, 3, negative 3, 1, 2, 3, 4, negative 3, negative 4. So let's write that down. So I have, and I'm going to erase this after. So I have a negative 3, negative 4. So the inverse would actually be 1, 2, 3, negative 4, 1, 2, 3. So that point will be right here. So I'm done with that. This point is at 0, 2. So it's 0, 2. The inverse will be switch. 0, it will be 2, 0. Oh, this is negative 2, sorry. So when this is switched, this is going to become negative 2, 0, which will be, this is negative 1, negative 2, 0 right here. Once I'm done with that part of it, we're going to continue and work with my other point. So let's take this away. This point here, I see it's 1, 2, 3, 0, 3, 0. So the inverse is actually going to be 0, 3, 0, 1, 2, 3, which is right here. And then this point right here, 1, 2, 3, 4, 5, 6, 2 is going to actually be 2, 6. So this becomes 1, 2, 1, 2, 3, 4, 5, 6. So I will graph my inverse function, and I will change the color of the graph so that we can see this looks something like this. So the green is my inverse function. I'm going to take these off. So all I did to graph this was to look at each point. I saw there were 1, 2, 3, 4, 5 points. I listed it and then just found the inverse, just like what we did. We switched the x and the y. So now that I have this, it is so much easier for me to find f of negative 1 to the second, which is f inverse of 2. So I'm going to be looking, let's label this. This is f inverse of x, and this is f of x. So I want to find the inverse of a positive 2. So when x is positive 2, the inverse is 6. And the f inverse of negative 4. So I look for where x is negative 4, negative 1, negative 2, negative 3, negative 4. Go all the way down to negative 3. Determine the x-intercept. So the x-intercept is right here, where the graph intersect the y. Determine the y-intercept. So the y-intercept is right here where the graph intersect the y-axis. So in this case, it is at 0, 3. Or you can say the y-intercept is at 3. Y-intercept equals 3. Notice this was in our f of x function. This was my my x-intercept. So when I do the inverse, it becomes my y-intercept because this coordinate and this coordinate are inverses of each other. On the set of axes below, graph f inverse of x, which we did in green. Now, this is the easy part. Whenever you have a table, all we're doing is switching the x and the y value. So a table of values for a simple quadratic function x squared is given below. Graph the inverse by switching the order pair. So if I was to switch this is my 4, this is negative, this is negative 2. This is positive 1. All I'm doing is switching my values. That's it. 1, 1, 4, 2. And then you're going to take a minute and graph this. Pause the video and graph it. Yep, there you go. That's your graph. It should look like something like a U to the right. It says, what do you notice about the inverse? So the first thing that I can see here on the inverse is that the vertex is the same. So the vertex is the same, which is at 0, 0. What else? A graph just kind of tilt to the right, and you can write all of that in. The main part of this is finding inverse from a table. All we're doing is switching my x and my y. Now, how do we find inverse algebraically? So there are 4 steps that we need to follow, and 4 simple steps that will work through any problem. We have to know these 4 steps for the regions. The first one says I'm going to replace f of x with y. It can be g of x, any function name. Switch my x and y, solve for y, and then replace my y with f inverse of x. So the first question says, given that f of x is equal to 6 minus 11, find f inverse. So the first step says replace it. Y equals 6x minus 11. Step 2 says switch these, x and y. So this is x equals 6y minus 11. I did 1, I did 2. 3 says solve for y. So I'm going to add 11 on both sides. This is cancel. X plus 11 is equal to 6y. To get y by itself, I'm going to divide by 6. The 6 is canceled. I'm just going to come over here. Let's draw this arrow up here. X plus 11 over 6 is equal to y. Bam. Step 3 is done. And 4 says just replace this with f inverse of x. This becomes x plus 11 over 6 is equal to f inverse of x. And this is my final answer. See? Step 1, 2, solve for y, 3, and then replace step 4. Let's see one more example. If g of x is equal to 4x plus 31, find g inverse. So the first thing I'm going to replace g inverse with y. Y equals 4x plus 31. That's my step 1. 2 says I'm going to switch my x and y. X is equal to 4y plus 31. And then I want to solve for y. So I'm going to minus 31 on both sides. And I'm left with x minus 31 equals 4y. Divide both sides by 4. This is cancel. And I'm left with x minus 31 over 4 is equal to y. This is my step 3. Step 4 says I'm just going to replace my y with g inverse of x. Why g? Because that's the name of my function that I was using. Little note, existence of inverse function. A function will have an inverse that is also a function if and only if it's a one-to-one. Hence, quick check is to do the horizontal line test. Once the graph passes the horizontal line test, it means that it will have an inverse. How do we show that functions are inverses of each other? So two functions f and g are inverse of each other if the following statement is true. F of g of x is equal to x and g of f of x is equal to x. Only functions that are one-to-one have inverses. And remember, to check if they're one-to-one, we need to do the horizontal line test. So to check if this is true, we do the horizontal line test. So I have exercise 6. I want to verify that these two are inverses of each other. So there are 2 things that I need to do. I need to show that f of g of x is equal to x, and I need to show that g of f of x is equal to x. So the way I do this is, first of all, what's g of x? G of x is x minus 5 over 6. And I want to find what's f of x minus 5 over 6. So I'm going to use my f function, which is right here. And I'm going to say 6 parentheses x minus 5 over 6 plus 5. My 6 are cancels off. And here I'm left with x minus 5 plus 5. Minus 5 plus 5 is 0, and I'm left with x, which is exactly what I needed to show from up here. Now, I have to do it for the other way. So, f of x now, work on my inside my parentheses, f of x is 6x plus 5, and then I want to find g of 6x plus 5. Okay, did my inside parentheses, and then I went towards the outside. So this becomes, my parentheses is 6x plus 5, minus 5 is on the outside, over 6. 5 minus 5 I know is 0. I'm left with 6x over 6, which is the same as x, which is what I started with. Correct? Excellent work. Moving on to example 7, I want to show the same exact thing, that these are inverses of each other. So I have to start with f of g of x. I want to show that it's equal to x, and I want to show that g of f of x is equal to x. So what is g of x? Work on the inside out. G of x is equal to 40 minus x over 7. So now I want to find f of 40 minus x over 7. You can do this. So I'm going to use my f function right here. This becomes 40 minus 7, but instead of x, I'm going to put all of this, 40 minus x over 7. My 7's are cancel, and I'm left with 40 minus, and notice I kept my parentheses, okay? Then we distribute this 40 minus 40 plus x. This will give me x, which is exactly what I wanted. So let's try this one out. So I'm going to start with my inside, which is f of x, 40 minus 7x. And then I'm going to go to g, which is 40 minus 7x. This is going to be right here. So now I'm going to have 40 minus 7x. I'm keeping that in parentheses, all over 7. Before I do anything, I need to distribute this negative. This becomes 40, take away 40, plus 7x, all over 7. 40 take away 40 is 0. I'm left with 7x over 7, which is x, which is, I know the answer. So that's how, if both of these are equal to x, it means that these two functions are inverses of each other.